Hi, my name is Jinachi. Today I'm going to be talking about advanced manufacturing processes. The word advanced refers to something that is modern or something that has operates on a high technology. The concept of advanced manufacturing is a comprehensive exploration of modern manufacturing technology, digital transformation, and sustainable production system that shapes the future of industrial engineering and so on. So basically, this course entails the review of modern technology, sustainable systems, sustainable production system, and the evolution of technology from one dispensation to another. So let's start with the question, what is manufacturing? Manufacturing is a systematic conversion of raw materials into finished products through integrated processes combining machines, tool, labor, and energy. It encompasses design, material selection, fabrications, assembly, and quality control, forming the foundation of industrial and economic development worldwide. This is my definition. So according to this definition, manufacturing basically talk about the systematic conversion of raw materials into finished products. So they must be raw materials and finished product. Very essential in this definition is machine, tools, labor, and energy. So the concept of manufacturing talks about machine, tools, labor, and energy. So the various things we use all went through the process of manufacturing. Even the cell phone we use, were all manufactured from raw material to give us the finished product, which is the cell phone we use. The core discussion of manufacturing talks about the product designing, the selection of the materials, and the quality control, and so on and so forth. So when we talk about product designing refers to the conceptualization of the product, both the brainstorming, thinking, testing, building of prototypes and model, and the technical specification of this very product. Then down to the selection of the materials to find out the ideal materials, the function of the product, to know what material will be suitable for it, and then talk about the quality control, ensuring that the product remains consistent. Consistency is very, very key when the concept of manufacturing is being discussed, because a product has to meet a particular standard wherever it is found. For example, we talk about an iPhone. So wherever it's assumed that every product, every batch of iPhone produced delivers the same kind of function, except it's adulterated. So we have to talk about quality control to ensure that the quality of the brand of the products is being maintained. We're going to look at the evolution of manufacturing. So manufacturing has actually evolved from the pre-industrial era. When we talk about when manufacturing is all about manual craftsmanship with simple tools, such as hand tools, down to 1760 to 1900s, where we're talking about the steam-powered mechanization and factories. That was predominantly the industrial era. Then we talk about the 1900s to 1970s, where basically we're looking at the assembly lines and mass production. So down to the fourth evolution, that is between the 1970s to 2000, where we're now looking at the CNC, CAD, and CAM flexible systems. And so basically, a lot of people in Africa will think that the CAD and CAM technology is still in vogue, but today we're looking at something more complex, which is in the 2000 down to the present year, when we talk about the Internet of Things, artificial intelligence integration in systems. So that is where manufacturing is today. And if you don't follow the trend, you'll be left behind. I'd like us to have a very quick comparison between the traditional and advanced manufacturing processes. So looking at the traditional process, that's the conventional approach, relying on the material removal, forming, casting, joining techniques. When we talk about the advanced processes, we're talking about the non-traditional method, utilizing mechanical, electrical, chemicals, and thermal energy innovatively. So Basically, what we call the conventional system, the turning and the milling process, be it using the lathe machine, milling machine, a drilling machine to achieve drilling and grinding, welding, forging, all those systems. But when we now talk about the advanced manufacturing process, we're talking about electrical discharge machine, the EDM kind of system. Talking about the laser beam machines. So under the category of laser beam machine, there are a lot of machines. We have the laser cutting machines and so on and so forth. So we have the additive manufacturing, such as your 3D printers and so on and so forth, and every other kind of additive manufacturing system. Any additive manufacturing system refers to any form of manufacturing that involves the addition of various layers upon layers to form a finished product. And we have the electrochemical machining. There are lots and lots of them. So within the course of this very class, we're going to be discussing their uniqueness. Well, one of the things you will notice when it comes to the advanced manufacturing processes, you could see that most of the things are machine-based, technology-based, computer-based. Unlike the days where we had to use our turning and milling and drilling systems, even though we still make use of some of these equipments, but they are much more advanced in current times. So it's very important to understand that the traditional manufacturing process might seem very obsolete, but it's actually the foundation of most of the technologies we have in current times. So we've succeeded in talking about the meaning of manufacturing, and let's talk about advanced manufacturing. So according to my definition here, advanced manufacturing systems integrate cutting-edge technologies with intelligent controls to achieve unprecedented precision, efficiency, and adaptability. These systems represent a fundamental shift from conventional production towards data-driven, automated, and sustainable industrial operations. So the definition is kind of clear. So it talks about the integration of smart system, cutting-edge technology, artificial intelligence, computer systems in our regular kind of manufacturing processes. One of the properties of an advanced manufacturing system is that it has a very high precision. We're looking at precision as high as microns, very precise level of accuracy. So we are talking about automations. Gone are the days when things have to be done manually by human beings. So with the advanced manufacturing systems, things are automated, processes are repeated, with very minimal human intervention. So automation, basically with less human intervention, we're talking about the use of robotic systems, robotic arms in actualizing the goal or naturalizing the manufacturing processes in an industry. So we're also talking about the integration of CAD, sensors, CAM. So CAD being computer-aided design and CAM being computer-aided manufacturing systems. And we have various systems for computer-aided manufacturing processes. So we're talking about the CNC machines, talking about various kind of systems, the robotic systems that ensure that manufacturing processes becomes very seamless. So we're talking about adaptive control systems, systems that understand the behavior of men. So we're talking about sensors that senses various points, various part of a machine, no longer a person being the one automating, moving it or trying to make sure that certain level of activities are being carried out is actually automatic. Talking about sustainability, it's a kind of process that help reduce of waste. It increases energy efficiency because the wastage that men create as a result of fatigue and wear and tear, could actually be avoided. Sustainability, the manufacturing process is very sustainable, waste conscious, and enables the recycling of products, ensuring that the energy is actually efficient, because when we're using the conventional system, there are a lot of tear and wear, fatigue coming from the person working on the machine and everything. But in this kind of system, it's actually the machine based. So the wastage, the trial and error that men would have actually done are being prevented by machines like this. what are the core goals of advanced manufacturing processes? So advanced manufacturing systems pursue first interconnected objectives that drive competitive advantage, operational excellence, and responsible industrial practice in the 21st century. So the core goal is productivity, high throughput, and increased operational efficiency, ensuring that the system operates effectively. That when we talk about efficiency, we're talking about time, effectiveness, we're talking about the result, the output, the quality. So the level of precisions. So the essence of using advanced manufacturing is to ensure that what would have taken so much time can be done within a fewer time. What would have required many people can be done with few people. The possible errors that could actually occur during a manufacturing process caused by the inaccuracies of men would be eliminated. So another thing again is quality. So in advanced manufacturing system, the quality is always very enhanced. It's always consistent. Unlike the conventional system, in which various products can not give the exact precisions when you look at the products being produced from an advanced manufacturing process, you see that the products are defects free in most cases, unlike when the conventional systems are being used. So flexibility, rapid adaptation to new design and materials. Yes. So these systems are very flexible, thinking about the various kind of, the 3D printing machineries we have today. Today we have 3D machines that print concrete. We have 3D machines that print ceramics. You understand? They are very flexible and diverse. You can make corrections. You can adjust whatever you've done, through in a system, unlike the conventional kind of design. We have sustainability, so minimize efficient energy use and waste generation. So today, when we talk about advanced manufacturing system, it's the system knows what to do. The system doesn't make trial and error. The system was built to accurately deliver the job. Unlike the days where, most of the things we do under subtractive kind of manufacturing, where we have to have a lot of waste trying to get a result. Then cost efficiency, reduce production and operational expense. Yes, this advanced manufacturing process ensures that the cost of running a factory or running a process would be cheaper, though it has the capital cost is very high, but the operational cost is less. So the cost, both in terms of human resources, they're lesser. It takes a lot of money to ensure that the system, a conventional system, runs effectively. We need a lot of human resources to ensure that things are being done. Key technologies enabling advanced manufacturing. The key technologies enabling advanced manufacturing. The first one is CAD and CAM, three-dimensional modeling, simulation, automated tool, parts generation for precision manufacturing. So the word CAD and CAM is computer-aided design and computer-aided manufacturing. Use of computer in the design and in the manufacturing of various kind of system and various kind of processes or designs generally. Under CAD, we talk about the use of softwares like SolidWorks, AutoCAD, Fusion 360, and so on and so forth. So three-dimensional modeling helps us see the design in 3D. We can carry out simulations, automated tools, parts generation for precision. So softwares or tools like CAD softwares that helps us design, helps us examine the processes is very essential. So let's talk about the CNC machines. So CNC machines are the computer numerical control machines. So they are computer controlled. They enable high level of precision and repeat machine processes. A lot of times ensuring the same level of accuracy, unlike the days when we are using the conventional system, whereby the products are not consistent. But with a CNC machines, the products are always very consistent. Repetition is very, very easy, and precision is always easily achieved. So robotics, so automated systems for assembling, handling, and material transporting with minimal human oversight. Yes. So in advanced manufacturing today, we have robotic systems, that's robotic arms, even the conveyors. that converts system from one point to the other, using sensors to understand when whatever function needs to be carried out, having actuators and so on and so forth. It is being achieved under advanced manufacturing. So additive manufacturing is a manufacturing process that place various layers of materials on each other to ensure that a complex geometry is achieved. It's basically used for rapid prototyping. However, it might be difficult for mass production due to the time it takes to achieve this very product. So Internet of Things connect machines and real-time data analytics from the predictive monitoring and optimization. So when you talk about the concept of Internet of Things, these are the system that captures the real-time data to work with a system. For example, with the help of Internet of Things, a machine can identify a system, identify a person, identify a process, and then transmit it to another kind of system. So it's just like a machine being able to have an eye to see what's happening around and analyze it and tell you what it is. With the help of artificial intelligence, predictive maintenance are being done, defect detection, intelligent process optimization, and AI has actually played a very key role in advanced manufacturing to ensure that there is predictive maintenance before there is breakdown. It predicts the maintenance and then makes the whole process very intelligent. In advanced manufacturing, we are talking about digitalization and sustainability transformation. So it's very essential to understand that in our current time, digital manufacturing and sustainable manufacturing is very essential, because we're not just designing system or producing system. We are producing systems that are sustainable, systems that wouldn't deplete the resources in our society. So let me give you a brief explanation of what digital manufacturing is. So integration of digital twins, real-time analytics, and cloud computing create smart factories where physical and virtual systems operate in seamless systems. This enables predictive maintenance and optimized production. Digitalization and sustainability transforms industry. In advanced manufacturing, it's very, very important to talk about digital manufacturing process and also sustainable manufacturing processes. So under digital manufacturing process, we're talking about the integration of digital twins, real-time analytics, and cloud computing that creates smart factories where physical and virtual systems operate seamless synchronization. This enables predictive maintenance, optimized production scheduling, and immediate quality feedback loop. What this actually implies is that when you're working with advanced manufacturing systems, they are smart. They understand the behavior of the system. They will understand the process of production or the process of manufacturing your product, and can give you a feedback loop telling you about what has happened or what has been altered. So the more you work with this advanced systems, the smarter they become. Think of it as the use of robotic systems in actualizing certain kind of product, maybe in an automotive assembling plant, whereby these robotic arms pick, things from one point to the other. So they are not just working alone, they are also being updated with the various, with information coming from the system, from the cloud, to further enhance their output. Adoption of energy efficient equipment, renewable energy sources, recyclable materials, and green technology fundamentally reduces environmental impact. This approach aligns industrial production with global sustainable objectives and regulatory requirements. When it comes to manufacturing, there are rules, there are regulations. You shouldn't operate with systems that would hamper the environment, cause pollution, or that would be hazardous to the people working in the system. So that's why when we talk about the use of advanced systems, they are less hazardous. The equipment are smarter and not like the conventional kind of systems where we have a lot of emissions. So let's talk about the real world application of advanced manufacturing in engineering. So one of them is when you look at companies like the GE Aviation that makes use of additive manufacturing. They use 3D printing systems or processes to print lightweight fuel nozzles for jet engines, reducing weight and improving efficiency. So let's talk about Tesla Motors. Tesla, the full complete assembling plants of Tesla are being managed by robots and artificial intelligence. So it's fully automated production line with AI driven quality control for electric vehicles. So let's talk about Siemens. So Siemens used Digital Twin for virtual factory simulation, optimizing processes before physical implementations. In Apple, we're talking about the use of CNCs and laser cutting machine for precise machining of aluminum casting using advanced CNC and laser technologies to actualize a good finished product. So the key takeaways is that advanced manufacturing represents the integration of digital technologies, intelligent automation, and sustainable practices to transform industrial production. Understanding this system is essential for engineers driving innovation in the modern global economy. 1. Manufacturing evolution from artisanal craftsmanship to Industry 4.0. Each era reflects technological advancement and economic necessities. 2. Technology integration. Advanced systems combines CAD and CAM, automation, Internet of Things, AI to achieve unprecedented precision and efficiency. Organizations must embrace digitalization and sustainability to remain competitive while addressing global environmental challenges. 4. Engineers' role. Final year and postgraduate engineers must master these technologies to design, implement, and optimize advanced manufacturing systems. These are the general importance or what we should learn from this very course. So I'll be giving you. So thank you very much for staying to the end of this class. I believe you've learned 18 or 2. If you have any question, you can write us on the comment section. In the next slide, I'm going to give you an assignment. I'd like to get your opinion on what you think about advanced manufacturing processes, or if you work with advanced systems, let us know under the comment section. Thank you.